Okay, we were looking at kilowatt hours in the last question, but what is it? It's simply the number of kilowatt hours, the number of kilowatts times the number of hours. Okay, so you can see it's kilowatts times hours. Okay, very simple thing to use. Let's have a look at an example. How much energy is used in kilowatt hours when a 100 watt light globe is on for 5 hours? So you notice that that is in watts, not in kilowatts. So we can either divide it by 1,000 to turn it into kilowatts and then times it by 5. Or look, with practice you just learn to recognise that's 0.1 kilowatts. Okay, multiply that together, we're going to get an answer of 0.5, and that's going to be in kilowatt hours. Okay, now the importance of kilowatt hours is that's how electricity is charged to us. So to work out the amount it costs us to run an appliance, we need to work out the number of kilowatt hours and multiply it by the number of dollars per kilowatt hour. Example 9, Tammin takes about 1.5 hours per week to iron his clothes. That's why I don't iron clothes, saves a lot of time. If he uses a 2,200 watt iron and the cost of electricity is that number there, I'm not going to read it out, calculate the cost of using the iron in 1 year. Okay, so he's going to be, to work out the number of kilowatt hours in 1 year, we take the number of hours that he's going to be using it each week, times by the number of weeks in a year. Then we need to multiply by the wattage or the number of kilowatts this goes through. And again, we could go 2,200 divided by 1,000, or again, just recognise that as being 2.2 kilowatts. We then, so what we've got so far is the number of kilowatt hours that it will use in a whole year. We then multiply it by the rate. Again, go to our calculator. Again, round that answer, so we're going to get $45.86. So not too big in the whole scheme of things for a whole year of ironing. Okay, so we've got electricity at 17 cents per kilowatt hour. Okay, so we've got a dishwasher that during a whole year is going to go through 670 kilowatt hours. So how much will that cost us? Well, just the number of kilowatt hours times the rate. So that many kilowatt hours at 17 cents per kilowatt hour. So we're going to go 670 times 0.17. Okay, so again, making sure you put your answer to 2 decimal places, we get $113.90. Okay, we've got a 2.4 kilowatt hour fan heater. It's on for 5 hours. So we work out the number of kilowatt hours by multiplying the amount of power it goes through by the number of hours. So the number of kilowatts times by the number of hours. We then need to multiply that by the rate. So 2.4 times 5 times 0.17. So that's going to be $2.04. So fairly cheap for keeping warm. Okay, a 20 watt LED light bulb for a whole year now. We're going to have to assume it's on all of the time. So what we're going to do is take work that in kilowatts. So look, it's probably safest for a number like that to just divide that by 1,000 so you don't make a mistake there. So we multiply it by the number of hours in a day times the number of days in a year, and then we multiply it by that rate of 17 cents per kilowatt hour. So 20 divided by 1,000 times 24 times 365 times 0.17. So we're going to get $29.78 there. Okay, so for today we're doing questions 1 to 7 out of 6.4. Okay, we want to work out how much energy is used in 8 hours of using each of these. Okay, so in part A, we've got a 100 watt light globe, so it's old style, incandescent, so the modern ones don't go through this much power. A lot of that turned into heat, but that's another story. So to turn that into kilowatts, we can either just divide that by 1,000, or we can just recognise that as being 0.1 kilowatts. We times that by the number of hours we're using it for. We're going to get 0.8 kilowatt hours. Part B, we've got a 20 watt compact fluorescent lamp. Again, look, it's for a number that small, it's probably safest to divide it by 1,000 and then times by 8. It'll get 0.02, so that should give us 0.16. Check that if it's wrong, and I'll owe you a Mars bar. Okay, a 12 watt LED light globe. Again, it's 12 divided by 1,000 times 8. Better do that one on the calculator. It's going to be too easy to stuff it up and cost myself lots of Mars bars. So we're going to get 0.096 kilowatt hours. Okay, and last one, we've got a 50 watt halogen light globe. Again, 50, safest to divide it by 1,000 to stop making any mistakes. And we're going to get 0.4 kilowatt hours. Okay, how much energy is used if it takes 2 minutes and 36 seconds to boil 1 litre of water in a 2,200 watt kettle? Okay, so we need to work out the answer in kilowatt hours. So we need to work out the number of kilowatts and multiply it by the number of hours, not the number of minutes and seconds. Now, 2,200 watts is just 2.2 kilowatts. Now, there's a great way to enter 2 minutes and 36 seconds or convert it to hours. We're going to use our degrees, minutes, seconds button. We're going to enter it as 0 hours, 2 minutes and 36 seconds. So you could write that down here in your working if you like. And so literally, I'll just bring the calculator onto the screen. Hopefully it doesn't, I don't know how well that'll show up. So we're going to go 2.2, just see if that'll, oh yeah, there we go. I'll try tipping it at an angle, see how that works. So 2.2 times, now you need to enter 0, then press your degrees, minutes, seconds button, then 2, press it again, then 36 and press it again. Okay, so it's important we enter 0 first for the number of hours. If we just did 2 DMS 36 DMS, it's as if the kettle had been boiling for 2 hours and 36 minutes rather than 2 minutes and 36 seconds. So we press equals. Now the calculator thinks we were trying to work out an angle, but of course we weren't. So what we need to do now is just press the DMS button again. You can see we get that answer of 0.095 and then all of those threes. And if you have a careful look, that's going to match answer C. Okay, quite a simple question. We need to work out how much energy is used for 5 hours at 0.78 kilowatt hours. Again, we just multiply the number of kilowatts by the number of hours. Again, safest to go to our calculator. There, we'll get an answer of 3.9 kilowatt hours. Okay, so if you were to look on page 262, there's one of those sort of funny yellow sort of arched energy labels there. We don't actually need to go and have a look at it, and in fact there's a bit of a problem if we do, because the question assumes that the washing machine is going to be used 250 times a year, but if you have a look at the label, it's actually going to be used every single day, so 365. But so we're just going to ignore the label. We'll just presume that the washing machine is going to be used 250 times a year. Okay, so basically that label says that if you only use a cold wash 250 times a year, you'll go through 45 kilowatt hours of electricity. If you only use a warm wash, you go through 547 kilowatt hours in a year. So I said you'll either use one or the other, but again, real life, sometimes you'll be using cold, sometimes a warm wash. Okay, look, all we've got to do here is take the number of kilowatt hours for the cold wash, divide it by 250. It's as simple as that. So 45 divided by 250. Again, just go to our trusty calculator. Okay, that's going to give us an answer of 0.18 and that's going to be in kilowatt hours. Similarly for the warm wash, we go the total for the year divided by the number of washes there. Okay, so that's going to be 2.188 kilowatt hours. So the huge difference in there is simply because of here we need to heat the water. And it can either, normally it's going to just be heated by your hot water service, but you need to take that into account. Okay, Simon uses a 1,500 watt steam mop for 30 minutes a week to clean the tiled floors of his house. How many kilowatt hours of energy does the mop use over a year? So again, it's the number of kilowatts, which is 1.5, times the number of hours that it's going to be used each year. So it's used for half an hour each week. We'll assume 52 weeks in a year. So multiplying that together, we'll get the how many kilowatt hours it uses during a year. So we'll get to 39 kilowatt hours. Part B, electricity is charged at 26.84 cents per kilowatt hour. So just be careful, this is in cents. We want an answer in dollars. So what we're going to do is take the number of kilowatt hours. We're going to move that decimal point twice so we get a number which is already in dollars. It's just safer than trying to convert after you've got an answer. So we're going to get, again, once we round it, $10.47. Okay, we've got a bar heater at 2.4 kilowatts. It's used for 5 hours a day during the winter, so for 92 days, and we know the cost per kilowatt hour. So we need to work out the number of kilowatt hours, so that the cost will be the number of kilowatt hours, which is going to be that 2.4 times the number of hours a day times the number of days. So what we've got there, so the number of kilowatts times the number of hours is used in winter will give us the kilowatt hours, and then we multiply it by this rate here. Again, we don't need to worry about the zeros at the end. Okay, going to our calculator. So rounding that off to the nearest cent, we'll get $318.17. Okay, we've got a front loader washing machine. It's going through 2.1 kilowatts when it's on. It's used 5 times a week. Takes 38 minutes to complete a cold water wash. Electricity is charged at that rate there. Again, just be careful, it's in cents, so you need to divide that. Okay, the total cost for 1 year. Okay, so we need to work out the number of kilowatts times the number of hours times the rate. So we get the total number of kilowatt hours. So it's the number of kilowatts there is 2.1. Now the number of hours it's going to be used in a year, which is what we need to do here. So we've got 38 minutes. So remember to enter that as 0 hours, 38 minutes there. We're going to be using that 5 times a week. Okay, yeah, 5 times a week there. The number of weeks in a year is 52, so don't multiply by the number of days because we needed to take that into account. So we've got the number of kilowatts times the number of hours it's going to be used in a year. Again, this is in cents, so let's convert that to dollars. And now we just type all of that in. Again, we're going to get a, the degrees minutes symbol, degrees minutes second symbol will appear at the end, but we just need to, again, so there's our, sorry, let's tilt that. Okay, there's our answer there. So we press DMS again. Sorry, didn't press it. So we get 103.12 as our answer. And remember that's total cost, so that's in dollars there. So we've rounded that to 2 decimal places.